Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Comparing basicity and nucleophilicity of sulfur-based anions versus oxygen-based anions. Moving on to the next step. Basicity is determined by how readily a species accepts a proton, which correlates with the pK of the conjugate acid. The conjugate acid of CH3CH2S is CH3CH2S, ethanethyl, pK 10.5, while the conjugate acid of CH3CH2O is CH3CH2O, ethanol, pK 16. A lower pKa of the conjugate acid means a weaker base. Since ethanethyl, pK 10.5, is a much stronger acid than ethanol, pKa 16, CH3CH2S is a weaker base than CH3CH2O. Sulfur's larger atomic radius and greater polarizability allow it to stabilize negative charge better, making the thiolate anion more stable and thus a weaker base. Moving on to the next step. Nucleophilicity in polar protic or aprotic solvents follows polarizability trends down a group. Sulfur, third period, is much more polarizable than oxygen, second period. Greater polarizability means the electron cloud of sulfur can be more easily distorted toward an electrophile, making CH3CH2S a better nucleophile than CH3CH2O despite being a weaker base. This is a classic case where nucleophilicity and basicity diverge when comparing atoms in different periods. And for the final step. A. Incorrect. CH3CH2S is not a stronger base than CH3CH2O. B. Incorrect. CH3CH2S is not a stronger base, and it is actually more nucleophilic, not less. C. Correct. CH3CH2S is a weaker base. Thiolate is more stable, pKa of conjugate acid 10.5 versus 16, but is more nucleophilic, greater polarizability of sulfur than CH3CH2O. D. Incorrect. CH3CH2S is indeed a weaker base, but it is not less nucleophilic, it is more nucleophilic. Therefore, the correct answer is C. Therefore, the correct answer is option C.